In Lesson 6, Paul demonstrated that a MicroPython program like the one in Assignment 4 doesn't have to get very busy before it starts to fall behind reading the constant stream of data from the UART buffer. If this is allowed to continue, the buffer can overflow, garbling the NMEA sentences or losing them completely. Paul challenged us to report data similar to Assignment 4, but to move the buffer reading function to Core 1. In this way, buffer management would be unaffected by any parsing, calculating, file saving, etc., which would continue to operate on Core 0. If you're unfamiliar with dual-core Pico programming, you may want to have a look at Pico W Assignment 67. There's a link to that assignment in the description below this video. As in Assignment 4, this program watches the GPS fix pin to determine when a fix is achieved. The fix pin logic in Lesson 6 is a simplified version of the Assignment 4 code. Let's have a look at the code. As usual, our program starts with imports. We import pin because we're going to use the pin statement. We import UART because we'll be communicating with the GPS using channel 1 of the Pico W UART. We import _thread because we'll be using both Pico W cores, and time because we're using the time functions. Lines 11, 12, and 13 declare the pins we'll be using. The TX and RX pins are the Pico W UART transmit and receive pins that communicate with the GPS module. The fix output on the GPS module is connected to the fix pin on the Pico W. Next, we declare the objects used in this code. Fix status echoes the fix LED on the GPS module. UART1 transmit and receive objects are used to create the GPS object on line 21. We declare some of our variables on line 26 to 30. Core 1 is stopped is a flag which tells us when the program on Core 1 has stopped. Fix limit is the minimum number of seconds between fix LED blinks that signifies we have acquired a fix. Gotta fix indicates whether we have a fix or not. Shared data is used to pass NMEA data between the Core 0 and Core 1 programs. And stop Core 1 is a flag generated in Core 0 which will stop the Core 1 program when it is set. This is a simplified version of the fix status ISR from Assignment 4. When execution first comes to line 48, we set the previous fix pulse start to the current time. Fix status is then defined as an interrupt on line 49. From then on, whenever the fix LED comes on, the fix status pin goes high, triggering the interrupt and calling the interrupt handler fix status ISR, defined on line 35. Fix status ISR measures the period between fix LED blinks. If the period between two consecutive blinks is greater than fix limit, gotta fix is set to true. Otherwise, gotta fix becomes false. The read GPS on Core 1 function runs on Core 1. While stop Core 1 is false, the program messages the user, waits in the do nothing while loop on line 58 until we have achieved a fix. In other words, gotta fix goes true. Messages the user again, waits in the do nothing while loop on line 61 until data appears in the UART buffer, and the while loop on line 63 reads all the data from the UART buffer into a throwaway variable, clearing the buffer of any unpredictable, possibly corrupt data. We message the user one last time. Now that the GPS UART is a clean slate, we erase the raw sentence variable and begin to read fresh data from the GPS. The loop starting on line 67 will run until either stop Core 1 is set to true or we lose our fix. The loop starting at line 68 runs whenever the GPS buffer has any content. We read one character at a time from the UART buffer, strip off the byte indicator, and save it as GPS character. NMEA sentences start with a $sign character. So if GPS character is a $, we start a new raw sentence. If GPS character is any other character and raw sentence is not blank, GPS character is concatenated to raw sentence. NMEA sentences always finish with the new line escape character \n. If GPS character is \n, raw sentence is a complete NMEA sentence, so we can share it with core 0. The program acquires the GPS lock, splits raw sentence at every comma, and assigns it to the shared data variable, which will be read by core 0. Finally, we release the GPS lock, reset raw sentence to nil, and repeat the loop to read the next NMEA sentence. If we lose our fix, we exit the line 67 loop. Execution returns to line 57. We message the user and wait to reacquire our fix. We will soon see that if the user presses Ctrl+C, stop core 1 will be set to true in core 0. Execution falls out of the line 56 loop to line 80, which acquires the GPS lock, sets the core 1 is stopped flag, then releases the GPS lock. That closes the core 1 program. The GPS module can also accept commands. The command shown on line 99 was suggested by another of Paul's viewers. It enables the transmission of GPVTG NMEA sentences, which some users reported to be missing from their output. Line 104 initiates the read GPS on core 1 function on core 1. Line 105 establishes the GPS lock, which prevents the two cores from garbling data by writing to the same variable at the same time or trying to read a variable while the other core is writing to that variable. At line 106, we enter the familiar try except clause with an included while true loop. If the got a fix variable is true, the program acquires the GPS lock, copies shared data from core 1 to the snapshot variable, and releases the GPS lock. If snapshot is not null and contains a GPGGA sentence, the latitude and longitude components are extracted. Latitude is negated for users in the southern latitudes, and longitude is negated for users in western longitudes. The number of satellites is extracted on line 119, and we print our results on line 120. The loop repeats after a brief sleep on line 121. If the user presses Ctrl+C, execution falls to the accept clause on line 123. We message the user and set stop core 1 to true, and wait for core 1 is stopped to become true. We've seen the code that manages this just previously. Finally, we deinitialize the GPS, sleep briefly, then message the user that the program has stopped cleanly. And here's how it works. The program waits for the fix LED period to be longer than 10 seconds. Once we have a fix, we clear the UART buffer, update the user, then read the GPS data. This section of the video has been sped up for your convenience. And pressing Ctrl+C stops the program cleanly. Well, that's it for this assignment. Any and all comments are welcome. Don't forget to like or dislike the video before you go. And feel free to subscribe. Don't forget the notification bell. We'll talk to you next time.